आज तुम्हारा एक टॉपिक जो स्टार्ट करूँगा वो है तुम्हारा 3 हिंज आर्च। तो ये तुम्हारा 3 हिंज आर्च जो है वो डिटरमिन स्ट्रक्चर है। एक यहाँ पर क्राउन जो है, क्राउन में एक हिंज होगा एंड दो एंड साइड में 2 हिंज। तो ये 3 हिंज आर्च में जो सपोर्ट कंडीशन है, यहाँ पर 2 सपोर्ट कंडीशन है। जो हिंज है यहाँ पर एक वर्टिकल रिएक्शन आएगा, 2 एंड में 2 वर्टिकल रिएक्शन आएगा एंड 2 एंड में 2 हॉरिजॉन्टल रिएक्शन भी आएगा। ठीक है, तो तुमको ये कैलकुलेट करना है कि वर्टिकल रिएक्शन क्या है एंड हॉरिजॉन्टल रिएक्शन का वैल्यू क्या है। मान लो ए बी 2 एंड पॉइंट है एंड सी है उसका क्राउन, ये भी एक हिंज पॉइंट है। ओके, सो वर्टिकल रिएक्शन यू कैन रिप्रेजेंट इट बाय वी ए and VB, and horizontal thrust you can represent by HA and HB. So you have to calculate vertical reaction and horizontal reaction. So let us take an example to understand how can we calculate. So this is a 3 hinge arch subjected to a UDL. तो इसका वर्टिकल रिएक्शन कैसा कितना होगा, A, B, C. So let us consider this arch like a beam and you just calculate the vertical reaction like that. Okay, so this is A, this is B, and total distance is L. So total distance is L. So now the reaction is VA and VB. So if summation of vertical equals to 0, so VA plus VB minus WL equals to 0. This is one equation, and another equation is summation of moment equals to 0. So taking moment about point A, if you take moment about point A, so VB, force VB multiplied by L, it will give you anticlockwise moment, and let us consider anticlockwise moment is positive, so W will create a clockwise moment about point A. So this is negative W into L, this is load into L by 2 equals to 0. Hence VB into L equals W square by 2. So VB equals WL by 2. Hence VA is also WL by 2 from equation 1. So now VA equals WL by 2 and VP equals WL by 2. Now Now you have to calculate horizontal thrust at point A and at point B. So this height h is given in the question. Span length is L. So to calculate the horizontal thrust, you have to take the moment about point C only. Okay. So you can consider the left portion or right portion, whatever it is. Now taking moment about point C. So let us consider the left portion. This is WL by 2. This is HA and this is W. So if you consider the moment center is A, so WL by 2, this VA will create a clockwise moment. So force multiplied by distance from A to C, this is L by 2. It is clockwise moment. Let us take the clockwise moment is positive, and HA will give you anti-clockwise moment. So minus HA multiplied by H, the perpendicular distance from A to C, with the direction of HA, and UDL W will create an anti-clockwise moment. So minus W into L by 2, this is the load, and the distance is L by 4 equals to 0. So HA into H equals W L square by 8 minus W L square by 4 equals W L square by 8. Hence HA equals W L square by 8H. Okay. So if you create the equation, that is summation of horizontal equals to 0, that is HA minus HB equals to 0. From this equation we can calculate HB is nothing but the value is same, that is WL square by 8H. So this is the 3-hinge arch subjected to IUDL W per unit. This is point A, point C, point B. The vertical reaction will be WL by 2 at B and at A, and the horizontal thrust will be WL squared by 8H at A and at B. So this is the final result. Now let us take another example. So this is 3-hinge arch. subjected to a UDL of 60 kilonewton per meter, and 2-point load, one is 100 kilonewton, another is 160 kilonewton. The crown height is 10 meter. And the span is 30 meter. So first of all we have to calculate the vertical direction at A and B. To do that, we can consider the arch like that. So summation of horizon vertical, summation of vertical equals to 0. So BA minus 60 into 15 minus 100 minus 160 plus BB equals to 0. This is first equation, and another equation is summation of moment equals to 0. So taking moment about point A, so VB into 30 anti-clockwise moment minus 160 into 25 minus 100 into 20 minus 60 multiplied by 15. This is the force, and the distance is 15 by 2 from point A, so equals to 0. Vb is equal to 425 Newton. Now from the equation A we can calculate the VA. I can calculate the VA. So VA equals (16 to 15) plus 100 plus 160 minus 425. So VA will be 735 kilonewton. kilonewton and 425 kilonewton. Now you have to calculate the horizontal thrust. So let us consider one side. So taking moment about point C, 735 multiplied by 15, it is clockwise moment, minus HA multiplied by 10. It is anti-clockwise moment, minus 16 to 15 into 15 by 2. It is anti-clockwise moment, so equals to 0. So HA into 10 equals hence HA equals 4275 divided by 10, so 427.5 kilonewton. Now summation of horizontal equals to 0, so HA equals to HB is also the same value, 427.5 kilonewton. For 27.5 kilonewton. Let us take another example, that is a parabolic arch subjected to a UDL. The value of UDL is 20 kilonewton per meter, and the span length is 20 meter and the height is 4 meter. Now you have to calculate the maximum bending moment for this arch. Before that, first of all, you have to calculate the vertical reaction and horizontal thrust at A and B. So to do this, summation of vertical equals to 0, make the summation of vertical equals to 0, VA, the vertical reaction at point A, minus 20 into 10 plus VB equals to 0. So this is one equation, and another equation is summation of moment equals to 0. So taking moment about point A, now VB multiplied by 20 equals into 10 into 5. So VB equals 50 kilonewton. So from equation 1 we can get the value of VA equals 200 minus 50, that is 150 kilonewton. So VA 150 kilonewton and VB 50 kilonewton. Now you have to calculate the horizontal thrust. So let us consider the right side of the arch. Taking moment about point C, so 50 into 10 anti-clockwise moment minus hb into 4 equals to 0. Hence hb equals 50 into 10 by 4. So hb equals 125 kilonewton. So now summation of horizontal equals to 0. So HA equals HB equals 125 kilonewton. Now you have to calculate the maximum reaction. Before calculating the maximum reaction, you have to find out the position of the maximum reaction. Okay, so let us consider a section. Let us consider a section that is at x distance apart, and this is y. At x distance from A, we can get the maximum bending moment. Okay, so first of all you have to calculate the x value. How can we get that? This is a parabolic arch, that's why the formula of x and y is like that. Y equals 4h divided by L square into x into L minus x. Now put the value of h and L. The value of h is 4, the value of L is 20. So 4 into 4 by 20 square into x into 20 minus x equals x into 20 minus x divided by 25. Now calculate the bending moment at this section x. At section x equals you can see 150 will give you clockwise moment and horizontal thrust 125 give you the anti-clockwise moment, and the UDL between A to X will give you anti-clockwise moment. So 150 into X into X minus 125 into Y minus 20 into x square by 2. Now put the value of y in terms of x. 150 into x minus 125 x 20 minus x by 25 minus 20x square by 2. The simplified form of this equation is 50x minus 5x square. Now the condition for the maximum bending moment is dmx dx equals to 0. Okay, this is the condition. So we have to satisfy this condition. Now ms equals x minus 5x square dmx dx equals 50 minus 5 into 2 into x. So 50 minus 10x, and it should be 0 according to the condition. According to our condition, it should be 0. Hence 50 equals 10x, so 10 equals 5 meter. So we can say that at 5 meter distance from point A, the bending moment will be maximum. Now put the value of x. If you put the value of x in this formula, you get the bending moment value. Okay, so bending moment, maximum bending moment will be 50 into 5 minus 5 into 5 square. Hence the maximum bending moment value is 125 kilonewton meter. So this is the answer.